Hello, good evening, everyone. Hello, am I audible?
Yes, sir.
Yes, sir.
Okay, thanks for that. Okay, so today is we have the session for OPP, and this is not just like a full revision for the OPP. All topics we cannot cover in one session. So, but we will discuss some important topics. Okay, so for the OPP exam, where you can focus more for practice. Okay, as we have already shared some posts on the discourse related to this, but we will discuss some different variants. What are the possibility of the questions on that topics? So let me share my screen. Before that, if you have any query, you can also clarify. Okay. So I'll discuss again the structure of the OPP exam for PDSA. So there is only one OPP exam for the PDSA on this 17th, and there is one remaining slots is on 24th. Okay. So there are total three slots. This exam is happening, and all students are distributed in these three slots. So two slots are on 17th, and one slots are on 24th. And the pattern we have already mentioned that four problems will be there with equal weightage. You can see on the screen total four question with each questions have 25 marks. Okay, duration for this exam is 2 hours, and syllabus is till week 9. So this is the structure of the OPP exam, and all questions are mandatory. There is no choice. And now regarding the question distribution. So as we have mentioned, the syllabus is still week 9. So but there are lots of topic you have, and subtopics are interrelated. So we will discuss that what are the possibility of questions. So if we start from the first week, so first week is simple Python based. Okay, so we will start from the second week. So second week we start the sorting algorithm and searching algorithm. So here both are important. Sorting is very important because for to solve any type of problem, we required sometimes sorting on the data. So that sorting may happens on the simple Python list, or it may also be happen on the linked list. Okay, to solve the problem. So at least because you know many algorithms you have learned like this selection sort, merge sort, all this type of sorting algorithm you have seen. So at least some algorithms you can learn. Okay, so here generally we not test the complexity, or we also generally not ask the straightforward question. So like we will give the list and just ask to sort, because in Python you can directly use the built-in function. So related to sorting, sorry, related to the sorting, so generally questions is asked on the linked list. Okay, so linked list is the topic of week 3. So like as we have mentioned also, this one question will be based on the linked list. In here you can see one question will be based on the linked list. But what type of questions is possible on the linked list? So here there are many possible questions. So what basic operation you should know about the linked list? And that is fun. First thing is traversing. Okay, if you are getting a linked list in the input, and some operation is asked on the linked list. Okay, so traversing is the main important operation you should know for the linked list. So traversing, so this is the must operation you should practice on this. Another operation is just like the basic operation on the linked list that is required for create and delete the node, like create a linked list or insert a new node or delete a new node. Not delete a existing node. Okay, so insert, I'm just writing insert and delete. Okay, so this is very common operation which is required for any type of operation. But insert a node, that may be happen on different position. So like first position, and like any given position like kth position and last position. Okay, so there are three possibility of the questions to insert a new node on the existing linked list. Same for the delete. We can ask like delete the first node or kth node or last node. You will always get a structure in the exam, that will represent the singly linked list. Okay, means you will get a head, and that will contain the reference of first node. Okay, so this will be the structure for linked list, which will be given to you in the exam. Like, okay, so means head is the first variable, you can say, that contains the reference of the first node, and then first node contains the reference of next node. Each node will contain the value like data and next. Okay, like these two fields. So this is the singly linked list structure. Generally we use this for the OPP exam questions. So this structure will be given, and you can see this structure in the questions which we have released in the mock. So same type of structure you will get in the exam also. So here you can see. So head is given, linked list structure is given, last node next field contain the null value in the Python. So class each node structure is also given. So data is the one field that contain the data, next contain the that next node address if that exists. Okay, otherwise none. And you will get a like a head as a reference. Like here in this person, head is given as in the reference, and we are asking that remove the duplicates value from the linked list. So means remove the duplicate nodes. Here there is a one general problems that a student faced during the OPP exam. So here we are giving some structure to you. Okay, so if you are performing simple traversing operation, there is no problem. Okay, so but if you are performing like this operation, insert and delete, so means you are adding some new node into the existing list, or maybe you are removing the nodes from the existing list, and this input linked list have this type of structure. Okay, so after performing this insert or delete type of operation, that will update the structure actually. So maybe you will add new node at the last. Okay, so what happen generally when you delete the node, suppose if you are deleting this node, middle node, okay, this node, but what happening, you are not actually updating the pointers correctly. You have done this operation, but after that you have not correctly updated the pointers of the remaining nodes correctly, and maybe you left this node like none with not none, just a next address, or maybe some reference, or maybe you disconnect this, or you put this like empty or something. So some case maybe so what happened actually in suffix code or maybe hidden code, that is generally validation code which we have written in the questions, that actually traverse the same list and check that your operation is performed correctly or not. So that is also a one simple traversing code. So that will generally traversing from the first node to last node, but maybe due to some incorrect code. Okay, maybe you have incorrectly disconnected the pointers or something, you have not updated correctly. So what happened, that code actually runs infinitely, that will not stop actually. Okay, the code runs infinitely, or maybe you have set the condition while like temp does not equal to like next. Okay, does not equal to none. So this generally condition is checked to when we will run this while loop, when we will reach at the last node. Okay, and then we will stop. But maybe you have updated all the nodes where there is no none is exist. Okay, so this loop will run continuously and it will not stop, and your code will give some something different behavior, like something went wrong, this type of message. Or generally students report this message to the proctor that some issue is there in the problem or like this. So this type of question, linked list question, if a person is asking about any insert and delete type of things, okay, if you are asking the like the insert node or delete node, so make sure that after performing the operation your structure should be well like defined as required. Okay, properly all nodes should be properly connected, last node should definitely contains the none value in the next field. Okay, so make sure that your structure is properly maintained after performing the operation, otherwise you will get this type of error, something went wrong. Okay, or maybe your page will not load, or some different type of issue will come, because that code is running infinitely and that is not stopping. So for linked list type of question, this is the main important point where you can just keep this thing in your mind when you are solving this type of question. Otherwise, simply if the question is asking traversing type of operation, that you can do without any modification. Okay, and this type of question generally asked on the in place. Okay, so in place means you have to perform the operation on the same input linked list. Do not create another linked list. Okay, do not create the list, or maybe what happens generally, students read the all data and perform that, or then print something, or like return something. But this type of question generally asks where you no need to return or print anything in your function, just modify the linked list in place. Okay, just means just update the elements on the in place, or add or delete in the same input linked list, and that linked list again will be traversed by the suffix code and validate. Okay, so make sure that this all information will be given in the question statement itself. That means do not print or return anything, only modify the linked list in place. So these are the basic operation that generally asked, like traversing is the basic operation, just to print the elements of the all linked list. So this is also used by the suffix code to validate the modification. Insert and delete, these are very common. So but if you know these basic operation, you can solve any type of problem on the linked list. Now other problems on the linked list may be like different type of use cases. Suppose sorting. Simply Python list you can easily sort. Okay, but if the elements are given in the linked list, then you cannot apply the built-in sort. Okay, so suppose elements are given in the linked list like 3, 5, 4, 2, like this. So and we are asking that the sort the same input linked list. Okay, do not create a like a new list, the same sort linked list, just sort this. So all elements should be come in the ascending or descending order as required. Okay, so for this you should at least know some of the algorithms which you can apply on this. And that basic algorithms you can apply selection sort, that can easily applied on this, because you can easily figure out the first position and just traverse the complete list and just see like which element is the smallest element, and then swap the values on that node. No need to change any pointers or address anything, only swap the value. Okay, so you can maintain like two variable temp that will maintain the position of where we are looking the element. Okay, and another like temp one that will traverse completely. Okay, and we'll figure out the which one is the smallest element from this temp position. And then suppose if you're getting this is the smallest, just swap the value here and then repeat the same process from the second place. So sorting in ascending order, descending order, these type of two main important use cases there on the linked list where sorting algorithm is required. Okay, because sorting you have also learned in the beak too, so you can think about that which sorting algorithm will be easily applicable on this linked list. Okay, so you can think about this now. We have already seen two questions on the mock exam, so where we are removing the duplicates. Okay, and we are merging two sorted lists. Okay, so another use case you can see, merging two sorted lists. You have seen these algorithms in the merge sort algorithm. Merge two sorted list. Okay, and here two sorted list linked list will be given like head one, and that will contain one linked list, and head two. Okay, now you have to create a combined sorted list after merging this head one and head two linked list. So you have to create another list like three, and you have to apply the same merge process which you have learned in the merge sort algorithm. So you have two sorted elements like 1, 3, 5, 8, and 2, 4, 6, 9, like this. So just here this is the linked list. So just maintain one temp variable on the first node, temp two variable on the second node. Okay, and just compare the element. So which one is the smaller? Just add a new node in the list and pass that value. So one. Okay, and move that point temp pointer which is moving. Okay, so temp like this will move here. So again, then compare the same temp 1 and temp 2 in the linked list, and then move the value, create a new node, and move the value in that too. Like, okay, in this way you can create a final merge sorted list, sorted linked list. So some algorithm, sorting algorithms, which is required, which you have to do on the linked list. So that type of operation. So this is the one which we have already given the mock, and duplicate removal, like finding minimum, maximum. Okay, these are very basic operation that you can apply on the linked list. And also partition. Suppose we are giving the linked list like 4 3 5 2 1 6 8 like this, and this is the linked list actually. Okay, all nodes are in the linked list. So like this, and we are just looking for just partition this linked list where the first node is pivot element. Okay, so pivot node, you are just considering the first node. So this is I hope you know this in the partition algorithm, in the quick sort algorithm. So how the partition happens? So partition happens means we take the one pivot element, and after that we arrange our elements in this way. So pivot element comes on the correct position in the sorted order, but before that all the smaller element like 3 2 1 will come this side, left side, and all the remaining elements like greater elements will come, 5 6 8 will come on the right side. Okay, so 4 will come at the correct position, but the greater element come on the right and small element will come on the left. So this is the partition for quicksort algorithm, but how you can apply this on the quick that linked list. Okay, so just see this how the partition happen, and this type of this problems also can be solved like if you just sort the list. Okay, that will also work, because partition is just a process where pivot element comes at the correct and smaller and greater comes on the left or right. So if you sort the list, still that will work. Okay, so and other possible problems you can think about that, you can search on the net. So what are the possible problems on the linked list? Okay, and structure you will get the same as the mock. Okay, so same type of structure you will get, but questions may be different. Removal, duplication we have already seen, and any type of problems maybe that can be created on that linked list. But the base of main operation is traversing, insert and delete, and some basic common algorithms you should know like sorting, searching. Okay, and this type of basic operation you should know, and partition, merging to sorted list like this, and that you can easily solve, and this is the easiest question in the OPP exam. Linked list question is generally the easiest question in the OPP exam. Okay, so this is the important part of the linked list, and sorting algorithms have already mentioned. So sorting is required, you should know. Okay, uh, so that how you can apply if that required in another data structure like linked list. Okay, so at least some algorithms you should know. Okay, so any query in this part, in this linked list part, if you don't know, if you have any doubt. So we are running a separate session in the detail for the details. Actually, Aditi is doing the sessions topic wise, and Aditi is also doing from the first week onward also that week wise topics. So, but linked list I have mentioned that just prepare yourself for at least these three operation: traversing, insert, and delete in the linked list. Make sure that your structure should not be affected. Okay, so that what is the singly linked list structure that should maintain after your operation, otherwise some unexpected behavior you will see. Okay, and some sorting algorithms information like merge sort process, partition process, basic algorithms that you have seen in the week 2, that is required, maybe questions require that. Okay, so one question you can definitely see on the linked list that may contain this type of operation.
Sir, only a single linked list. Mm,
Yes, only singly linked list questions we will ask, not the doubly linked list. Okay, doubly linked list we have covered, we have discussed in some assignments, but generally we not used for the exam. Okay. So what structure you have seen in the OPP mock questions, the same structure you will get in the exam also, but task may be different. Yeah, Basant.
Sir, hello.
Our voice is. हाँ Basant. Yeah.
Sir, so
Huh? What you are asking, I'm not understanding actually. Basant, can you repeat? Basant left.
hello.
Yeah, Kiran.
Yes, sir.
हाँ Basant, can you just repeat your question?
Sir, sorting algorithm related apply on this linked list. This type
हाँ,
of
so
problem.
sorting algorithm actually you have 4 5 algorithms, sorting algorithms. The purpose is same for all. Okay, so you should at least learn maybe 1 2 algorithms that can be easily applied on the linked list also. Like merge sort is difficult to apply on this. Okay, like quick sort is also difficult, but maybe selection sort you can easily apply it on this. Okay, so some basic
Okay.
algorithms, we are not checking efficiency on this linked list type of questions. So some basic sorting algorithms which you can apply it on linked list also, that you can see. But yeah, some other algorithms like merge sort, you should know how the merge happens. So that merge type of questions may also ask on the linked list. Partition type of questions may also ask on the linked list. So you should know the like part of the algorithms which we have seen in the sorting algorithms. Yeah, Kiran.
Sir, there is a mistake in the quick select lecture that I have posted in the Discord. There is no response.
That largest or smallest, no?
Yeah. So, is,
So that is, I
is
think,
it,
yes, you can figure out that professor is, I think, discussing the kth smallest, but they have used the term kth largest. Okay, so both problem are maybe easily can be solved. So if professor have discussed the kth smallest, kth largest may also be easily figure out that. Okay, but yeah, some term used differently. So yeah, that is the one thing. But
is
you
it
can figure
possible?
out that, and you can. Hmm?
So, like, is it possible to update it?
Video, we can just add some comments or anything, but we cannot modify that. But yeah, what notes and what summary we are providing, what like slides we are providing, we have updated everywhere.
No,
Okay, on the
maybe
video part, that this is only missing.
you can edit, no, when that.
Voice, actually, voice, prof
Notice.
voice, we cannot modify, but yeah, some we can give some comment
Yeah,
on
in the
that
video,
side.
it can be modified, no? I mean,
I'm
notice.
not sure. I'll check with the operational team so that if they can modify, so I'll check. Okay. Otherwise, if
Yes,
you,
in some of the city lectures, it's updated like that.
so I'll check this. I'll check this if they can modify this voice. So I'm not sure how much time that professor have used that term, or I have to check. So, but I'll check this. But that is, I think, kth smallest. Okay, so but if you are finding out the kth smallest, so kth largest is also very like similar type of algorithm, so that can be also be done. Yeah, Akash.
Sir, actually, I have some questions related OPP, sir. There is
Huh.
there is two questions related linked list, like find the duplicate elements or merging two shortlists. So we have to use any travel. Is there important to traversing this linked list, or searching and sorting
So
algorithm?
if
Yeah,
suppose if you are solving the finding duplicate, so means
mm,
traversing is definitely required now.
yeah.
If your list contain duplicate elements, so what you can do, you can simply traverse the list, like a head is given. Okay, and that contains the duplication problem is also maybe two types, where the elements that list is sorted and then duplicate elements are coming.
Yes. So
Okay,
we need to define
so
the
that
traversing. Yeah.
like I'm just giving the example.
Yes. Yes.
So here this 2 is coming, if this is sorted, so that is very easy. I think that is given in mock questions also. So if list is sorted, so definitely all duplicate elements will come as a adjacent elements. Okay, so that you can easily figure out. But if suppose this is not sorted, like 1 2 and 3 and then 1, so here duplicate is also there. So in this case, what you can do, you can just for each element, you can just traverse for first, second, and for the by the second loop. This is just like a nested things. For the first
Yeah.
element, you will look what is the value and traverse the entire list. At any place, if this is again coming, you can like remove this. This is depend on the question, what question is asking, or maybe if question is just asking what is the duplicate values, so you can simply keep the maybe for the result you can just store the result in some another place. So you can just check this 2 is repeating. Okay, so
So
just store in the dictionary.
while
Mhm.
traversing, if we catch the similar numbers,
Yes.
so we have to delete
For
this
each
two
element
and
you have to check. You
yeah.
have to check. So that is depends on the question. Question is asking to just return the duplicate value or delete the duplicate value. So based on that you have to perform the operation. But traversing is required. Traversing means you are visiting each nodes in the linked list. So some type of while loop you have to run. Suppose if
Yes.
you are setting temp equal to head like this.
Mhm. Mhm.
Okay, so
Yes.
then you have to take the condition like temp does not
Does
equal
not
to
equal to none.
like
None.
none. Like this
Yes.
type of loop you have to run, and
Uh,
inside this you have to traverse. You have to check the things or all the things, and you have to
oh,
update your temp equal to temp dot next every
we
time.
set the conditions over there. Yeah.
Like
Downside
this
of the
type
while.
of hmm, this type of loops you have to apply and traverse. So
Okay, sir.
each type of operation, if suppose if we are asking to delete the node, still you have to traverse. Suppose we are asking this node should be
Delete the
deleted,
node.
last node should be deleted. But still you have to run a traversing loop. Okay, so you have to traverse each node to reach at the last node. Because in singly linked list you have only head reference.
Yes.
To reach at the any particular position, you have to traverse from first node to that position. So this traverse operation is must required. After that, modification is the second thing. Insertion and deletion, that is just to update your pointers, update your reference. So that is
And
the
what
another
about, sir,
operation.
kth element? We should delete the kth element or insert the kth element. Is there required any
So that is
troubleshooting?
the update. Suppose we require k equal to 3. Okay, so
Yes.
third element is we want to delete. So third element is like this. Okay, so you have to set some counter here when you are traversing inside this while loop. Okay,
Mhm.
so here you have to take some counter condition. So like you can just set your count equal to 1 when you are at actually head. Okay, so to remove this node, remove this third node, you have to reach at the second node.
Yes.
Okay,
Uh-huh.
after that what update is required, so just this field. Okay, so this field you need to store the this field. Suppose this is the a field and this is b field. Okay, so b field contain the value address of this node next. Okay, and this a field contain the address of this two value node. And if you want to remove this two, so this means this a should be connected to the this field.
3.
Correct.
Yes.
Huh.
Okay.
So suppose if our pointer is reached at this value, so you need to
Temp.
simply write temp dot next
Temp dot next.
equal
Yes,
to temp dot next
dot next.
dot next.
Double next we
Okay,
have
so
to use.
temp dot next is will refer to this node, and this next will read this value. Okay, so that
Okay.
is the address of this node. So this is the simply assignment.
Okay.
Hmm.
Sir, can I take a screenshot?
What you want to take?
Screenshot, sir. Can I take a screenshot?
This is the recorded. Okay, so you can take later also, or you can take.
Yeah. Okay. Thank you. Thank you, sir.
Okay. So Sandeep is asking what is the today agenda. So we are just discussing the important topics where you can focus more for the OPP preparation. Okay. So we are not covering each and 9 week algorithms today. That is not possible also. but some problems where you can focus. Okay, so for the OPP exam that we are discussing.
Right, sir. Right.
Okay. Yeah. So this is the one question based on the linked list, but here the sorting algorithm, some part is required, sorting algorithm is also required, and this basic traversing and insertion and deletion operation is required. Okay. So now the comes to the next question. So next important question is like binary search. Okay, so second question, I'm just talking about binary search. Not, this is not a fix, but there is a possibility for that. Okay, so first question definitely on the linked list, one question on the graph algorithms. This is the fixed things. And other than this, like binary search based question, this is also very important for the OPP exam. So binary search question, you can easily figure out that if the question is asking the efficiency. Okay, if question is asking about the efficiency like log n time. Okay, so question is saying that write a efficient code with log n complexity. So log n means clearly indicate that your task should be like divide at each time into the half. So suppose if you have n input in the first input, then your problem space should be reduced by the half at every steps. Okay, then you can only achieve the log n steps, okay, to perform the task. Now you know about the binary search standard algorithms, so that where the sorted data is required, but the same type of approach may be used on some different types of problems, where the data have some pattern. Okay, where some data have the some pattern, like some example I am giving, not just only the sorted data. Okay, so this is the basic standard algorithm, 1 2 3 4 5 6 7, like this. You have the sorted algorithms, and we are just asking that to search something. So here straightforward binary search algorithm is required. Yeah, one more important thing, if you are implementing some binary search type of concept, do not use the slice operation in your algorithm. Okay, if you are like suppose if you are writing the recursive algorithms, and do not pass the list with the help of slice operation, because this operation by default is order of n operation. Okay, because this copy the half of the element and create a new list. So this if you are using this slice operation, this single operation is itself a big O n operation, then you cannot achieve log n time. Okay, then overall complexity will become order of n. So make sure that if you are writing any like iterative like logic or recursive logic, do not use like list slicing, okay, to achieve the log n complexity. And the thing is, binary search, the idea is very clear. Every time you have to remove half of your task. Okay, and this is the basic standard algorithm you have already seen, the searching binary search. But some other problems may also be asked that is very similar, that you can use the very similar approach, but that is some different task. So here some pattern will be given to you. Okay, if you can figure out that what type of pattern is there, and if you can just reduce your half size based on that pattern, then you can also use this binary search approach. So like suppose if I'm giving the very small examples, like you are giving a one uh, list 2 3 where the elements are given from 1 to n continuously. Okay, 1 to n, this is the supposed we want to just create a list where the each elements are there from 1 to n. Okay, so 1 2 3 4 5 like this n, but by mistake input is given in the same way, but by mistake one element is missed in this 1 2 3 4 5, like, and then we miss the 6 and then 7 then 8 9, and we are reaching n minus 1. Now this input is given, suppose, then we are asking that find out the missing element that in log n time. So how you can approach this question? Any logic, anyone?
So since it's sorted, we can apply binary search.
So but how you will figure out the missing element?
So we have to like update some. We have to do some changes in the binary cells. Like,
So what type of changes? How you will identify that where is the missing element?
so if
We are
um,
asking that what is the missing element? Only one missing element is there according to the question. Now, how you can figure out that missing element in log n time?
So the
sir,
number and
the
the
elimination
position will
will.
not match. Like some
Sandeep,
pattern is,
yeah, can you repeat, Sandeep?
if numbers are in some pattern, then
Hmm.
that position is supposed to follow a pattern and get a number to us. If
Yeah.
we check the index and that number is not matching the pattern, we can figure out whether missing is on the left or right.
Yes, correct. So here indexing is also going in the same way. Okay, so 0, 1, 2, 3, 4, like this. Okay, and indexing is there is no missing. Okay, so indexing is continuous. So you can directly look the middle element. Suppose you are looking the middle element, and you are checking this index. So by default, each element value index is one less. Okay, but here for 8, what you will get, index will be matched actually. 1, 2, 3, 4, 5, and 6. No, 7. 0, 1, 2, 3, 4, and 5, 6. Yeah, index will become like 6 here. Okay, so here by default the index should become one less, but when you're checking the middle element, you will see here indexing is mismatched. This should be 7, but you are getting 6. Means the element missing element is coming on the left side. Okay, and suppose if you are getting middle element is this, then here you can figure out that yeah, index is in proper. Okay, so here 5 is the value and 4 is the index. So here is index is properly matched with the value. So in that case, check the right part, not the left part. You can remove the left part completely and check in the right part. So this type of two questions is possible. Here the missing value is there. Another possible is where the one element is duplicate in this. Suppose 1, 2, 3, and same order is given. And I'm talking these questions because these question is asked in the previous OPP exam. Okay, this is not just like a new questions. Okay, so 1, 2, 3, and 4, 5, and some elements are repeated 2 times. Okay, and 7 and 8 like this. Here also the same logic will be applied. If you are checking the index 0, 1, 2, 3, 4, 5, 6, 7. So till you can see for till 5 or this till 6, first 6 index are properly matched, one less. But after that, any value you are getting the same value, same index. So means here some duplicate value is happened before that. So you should check before this. Okay, if you are finding any pattern. So binary search is not just like a one saying that one algorithm that is only applicable on sorted data. Okay, that is only one standard requirement. Here, some pattern if you can figure out in the ordering, and on based on the pattern that you can decide like remove the half of the part at every steps, you can apply that logic to achieve the login. So same, I think one question we have discussed in the live coding problems. I think so. Some increasing and decreasing order is given. So that is one thing. So like 1, 3, 5, 8, 10, and then like 9, 7, 6. Like this type of order is given. Okay. So this is just like a peak type. Okay. So at one place you are reaching at the peak, and this peak maybe comes in at any place. So this may be like 1 and 20, and then all are decreasing now. Okay, so here only one element and this is decrease. So this peak element may become at any place. Unimodal problem, yeah, we have discussed in one of the questions. I think that question is, I'm not sure, in given in mock also. So this is also one pattern, and another possible problem is that is also discussed in the assignments. If you are like, so list is sorted, but that is rotated, but you don't know how much time that is rotated. Okay, so 1, 2, 3, 4, 5, 6. Suppose this is the sorted, but if we rotate this, so you will get like a 4, 5, 6, and 1, 2, 3. Okay, suppose we have rotated this list 3 times, and we are giving this list to you. Then figure out that what is the maximum element in this and what is the minimum element in this in log n time. So here also pattern is there. You can see if you are figuring out just looking the middle element here, you will compare the all three adjacent element, and based on that you can figure out that where which side maximum element will come. Okay, so this problem is also discussed in some of the questions in maybe live coding and or maybe assignments. Okay, rotated list and some other patterns may also be possible. So you have to figure out that what pattern is given and how you can apply the searching process. Okay, just figure out that if you are comparing the middle element, then how you can identify that which side you have to check again. Okay, left side or right side, how you can figure out this logic. So in any type of log n question, just think about this, just check the middle element and check which side you have to look and how you can identify this by the middle position. Okay, so if you can figure out this logic, you can easily apply this binary search type of thing and achieve log n complexity. Okay, so log n complexity, I'm saying that always try to use like iterative approach first. Okay, iterative solution. Okay, if you are more comfortable in the recursive, you can also use the recursive approach in the binary search this logic, but do not use slicing in any case if your target is log n complexity. Okay, so this type of one problem you can expect for the OPP questions where the complexity will be checked for your code. And do not that questions will be looks like very easy by the naive approach. Maybe some in the previous question, if you see, if we are looking for the missing element, that this is very simply iterative solution. You can simply traverse and you can find out the missing element. But what will happen when you will run that code, your code will not pass the test case, because for that type of questions very big test case, maybe 50,000 or 1 lakh type of size will be given to the input. Okay, so your solution should be efficient for this. So do not ask to the proctor that my approach is correct, why this is not passing. So if just read the question statement carefully. If question is asking the efficient solution with some complexity, so just achieve that complexity in your solution code. Okay, do not try just basic like simple code and like check it. Some maybe one or two public test case generally we keep as a small test case that will pass by your n solution also. Okay, but big test case will fail. So just think that because a small test case, there is no matter time is actually very similar if you're using any type of approach. But that is you can see if your input is very big, then that time is actually clearly separated, log n and n. So make sure that efficient approach is required. So just read the question statement carefully and achieve your complexity. So one question generally asked on the based on the complexity. Okay, you can search what type of problems may be asked on the binary search log n complexity. Okay, and you can practice on that. Okay, any doubt in this? Any query for this type of problem?
So, sir, what would be the logic for finding this element?
Yeah, logic is depends on your pattern. What type of pattern is given in the input? Okay, and after some sequence will be given to you, and just check if you are reaching at the middle element, then how you can figure out that which part you need to check in the next iteration. Means you have to remove at least half of the input in one step to achieve the log n complexity. So this is totally depends on the problem. So in binary search, how you identified that where you need to look next. So 1, 2, 3, 4,
Element will
5,
be given, right?
7.
But in this case,
So you are checking the middle element and you are searching something here. Suppose you are searching like k value which is 7. So you are figuring out that because 7 is greater than 5. So greater means this should become on the right side. So here the identification is we are comparing the middle element and our searching element is greater than this. then you are looking only to the right and you are ignoring this part completely. So similarly, just see the input pattern. Okay, what input pattern is given. So like this type of problem where you are just reaching like this, input order is given, first increasing then decreasing, and we are identifying which one is the largest value in this. And same type of question may be asked like this type of decreasing and then increasing, what is the smallest element in this. So here what you will see, when you will just identify the middle element, maybe you can reach at this like order, okay, and you can maybe come at this type. So if you are reaching at this as the middle position, so here what type of order you will get? Here elements will be, suppose this element is like m, okay, middle element, and m minus 1 and m minus 2, okay, and not m plus 1.
Sir, is
So
this
just see,
you're talking about rotator sorted array?
what
So,
this is
which,
the peak unimodal problem. I think this is given in the mock question also. Okay, so suppose elements order is like this. So suppose this is the list, and 1, 3, 5, 7, 11, like 13, and then we are getting like 12, 10, 8, and then 6, 4, 2. Like suppose this order is given, and we are asking that what is the max element in this. And this list is very big actually. Suppose 50,000 elements are there. Then how you can identify that what is the max element in this type of order? And here just look this, what is order, what is the order, okay? And when you are reaching at the middle element, okay, so how you will identify that which side you should look actually in the next iteration, and how you can remove half of the part. And this max element may be on completely on the right side, completely on the left side also. So that order is also possible. Okay, suppose if order is given like 2 and 20, and then all remaining elements like 19, 18, 17 till 1. Okay, and then you can see this is coming here. So here this type of possibility where this type of such order is given, this is not a completely ascending order. Okay, this is first ascending then descending. So if you are looking the middle element, suppose this is the middle element, just compare with the neighbors, okay, and you will see 18, 17, and this side 16 will come, okay, if you order this. So here you can see this order is reducing to this side, okay, and means, or you can assume that this is increasing this side. So maximum element will come only this side, not this side. Okay, suppose if you're checking middle element, just compare with the neighbors element and figure out that which side element is increasing. So only to the left side of this, okay, so right side it is decreasing, so max element will not come on that side. So max element will only come on the right side. So here you can completely discard this part and just look this part on the next iteration. So in this way, just figure out that in the each time how you can reduce half of the input, but just by looking the pattern. Okay, so log n is means first step in each constant step. Like we are comparing the middle element, just remove your half of the inputs. Next time our problem size is half. So each time your problem size will reduce to half, then you will reach at the log n steps to the final solution. Okay, so this is the idea of the binary search problem. So just compare the middle element, check the middle element, figure out the pattern, figure out the condition where you can identify that which part to check next, and then you will achieve the complexity. Okay, Kiran. Mock question, I think some you can see this question is remove duplicate. We will discuss the detailed solution of these mock problems in Friday session. Okay, but before that, just try all the questions. So this is merge sorted linked list. Here in PPA4, you can see. Yeah, this is the problem. You can see this is the unimodal peak type of problem where the order is increasing then decreasing. So finding the max index. Here output is index actually. Output is index or what? Function it takes as input and return the index of peak element. Yeah, in log n time. Okay, so This type of problems. Maybe fifth problem is this is the different graph problem. Okay, so just look what problem you have seen in the week 2 and week 8. I think week 8 also we have discussed some this type of problem, and week 2 also we have discussed, okay, in live coding session also. So just see what type of problems where the complexity is log n required. Okay, so one problems on binary search type of things. Now moves to the next problem. Here some like memory is required, like you have to recall the algorithms actually. Third problem, I'm just looking here, graph based problem, graph algorithm. Okay, here many algorithms are there in the graph, but what are the important algorithms where you can remember or you can learn for the OPP
Can you
exam?
write the
One is
important algorithm?
BFS algorithm. Okay, so BFS algorithm or DFS algorithm. Okay, two algorithms are there, but you can use only BFS algorithm. So there are many applications like connectivity check. Okay, connectivity, connected component like this. Okay, shortest distance. Uh, that is the number of edge or number of vertex in the path. Okay, not the like weighted. So this is the shortest distance, maybe number of edges in path.
Shortest distance related to tags.
That is weighted actually, but if graph is unweighted, okay, suppose we are looking the shortest path in the terms of minimum number of vertex in the path or minimum number of edge in the path. Okay, so that type of shortest path you can apply this BFS algorithm. Okay, so this is also very, so this is not a straightforward question. That questions will have some story. Okay, questions I hope you have already seen some type of story based questions. So questions will contain some story. You have to figure out that what information question is asking. Generally this type of question, this type of information will be there. You need to identify the connect reachability, okay, or maybe shortest distance, or cycle also may be detected, but that is also not much important. But yeah, these two common applications are there. So you can apply this BFS algorithm. So I'm not saying learn both BFS and DFS, both the same thing. Shortest distance cannot be do with the help of DFS, but yeah, BFS is more important. So just learn this BFS algorithm. Okay, from the B4 I'm telling. So just remember BFS, and just also remember based on the adjacency matrix or adjacency list, both type of pattern. Okay, so maybe input maybe in this any form, or if you suppose if you remember the adjacency list algorithm, so what you can do, you can make the adjacency list from the adjacency matrix and then solve. So that type of conversion you should know. But BFS is important in the week 4. And another algorithm is like this DAG based algorithm, topological sort. Topological sort, where some dependency like prerequisite type of dependency based questions may be there. Some suppose course dependency is given, and we are asking that how much semester is required to solve or to complete all the courses. Or maybe suppose if graph is given, identified that that graph is a DAG graph or not. So this type of basic questions which can be solved with this DAG topological sort or BFS, some type of applications are there. So big 4 only this is important, BFS and this topological sort on the DAG. Okay, and big 5 there are only two topics: shortest path, weighted. Okay, so this is weighted path we are talking. Another is spanning tree. You have seen three problems for shortest path, three algorithms for shortest path, and two algorithms for spanning tree. So no need to learn all five algorithms for these tasks. Okay, so shortest path, just remember or learn one algorithm. I think the Bellman Ford is the easiest to learn. Okay, so Bellman-Ford, why I'm talking the Bellman-Ford, if you see the code of Bellman-Ford, that is very simple, and also that will also work on the negative weights. If suppose if question is dependent on the negative
Yes,
weights,
right.
okay, so if you learn the Bellman-Ford algorithms, you can apply that algorithm on the any shortest path problem where that if that contain negative weights, that still that will work. Okay, Dijkstra algorithm will not works on the negative weights. So because of that, I'm saying Dijkstra algorithm is also like complex like implementation compared to the Bellman-Ford. So just remember any one of the algorithms. I will prefer most of the students I have seen in the previous OPP exam, they writes actually Bellman-Ford implementation. That is like small code, and that saves the time in the OPP exam. Okay. Otherwise, Dijkstra algorithm is a little bit long code. And spanning tree also you can remember at least one of the algorithm, maybe which you are comfortable, either Prim's algorithm or Quetzal algorithm. Any one of the algorithm you can learn. So I'm mentioning here mainly these four algorithms actually. BFS at least, this DAG topological sort. Inside this there are two algorithms are there: topological and longest path in the DAG. Okay, so that longest path. So just both are important actually. Okay, and big five only one shortest path and one spanning tree. At least learn these 4 5 algorithms for graph algorithm, and one question definitely will come on this, and you have to solve the problem with the help of these algorithms. And just remember that question will have some story, some scenario. You have to figure out that which algorithm is suitable for them. Question will not be very straightforward like they just uh, apply this algorithm or this algorithm. Okay, so mock question is a little bit logical. Okay, so mock question what we have given, that is asked in the I think first term. So now generally we ask the easy question. So this is the graph algorithms you should learn actually. Okay, this is required. Here some some code we will give like suppose if Q algorithm is required for BFS. Generally, we give the implementation of Q separately. Okay, like stack is required in some place or any like required code is there, then we will generally give that code. But you should know the algorithms implementation for at least these 4 5 algorithms. So this is the
Sir,
main actually part where you have to actually remember the algorithms. Otherwise, other remaining problems only require the logic, okay? Not any particular algorithm. Yes, someone was talking.
Sir,
sir, for finding the missing number, in the sorted
Hmm.
diagram, so can we use this length function for that?
So, Kiran, I am not getting your question. Can you repeat again what you said?
So for the problem you are saying now finding the missing number, so can we use a length function for that? So
So okay, len function. So how you will identify the missing element by the len function?
I thought of something I forgot. Let me just.
So we are just looking the missing element, but len will represent the length of the list. That is okay, constant operation in the list, but you cannot figure out the missing element by that operation. Okay, think about that. What operation you are doing and what like cost is required. What step number of steps required, which you are doing. Yeah, Sandeep, you are talking something, I think.
yes, sir. In the spanning tree, if let's say we try to remember Kruskal's, then implementation is normal also and using union find also, that efficient union find. So again, we have to go in that direction also, sir. Or
Generally, graphs algorithm we not check the efficiency because actually on the portal implementation we cannot compare very close like time.
understood,
Okay,
understood.
so here log n and n is very different, much different. But if n square is there or something close is there, so that generally not we cannot compare in the back end. So generally we not check the complexity for the graph algorithms or maybe any DP algorithms or any type of algorithms. So you can write any type of approach.
Okay.
Okay.
So is there a dedicated question on union finds and all? Or no, it will be just
No, so that the union find generally we used. Okay, so that is like a generally not asked. Simply this graph algorithm spanning tree, shortest path, connected components, this dependency based questions like cycle detection or maybe DAG identification, that type of things. That are the possible questions in OPPE exam.
okay.
So this is the actually week 5 is where you required some learning on the algorithms, because that algorithm maybe you have to retain to solve the questions. So but if you understand the logic or concept without remembering, you can implement that. Okay, so that I'm not sure how much you are comfortable with the conceptual, like writing the code. But yeah, this is the question where some memory recall is required. Okay, now another part, like sometime some question may be based on the tree, and that will be the basic question. So like binary BST is given. Okay, so we have mentioned these questions on the mock also. So some tree is given, binary search tree. Okay, so here suppose if we are asking the maximum element or we are asking the minimum element, so how you can figure out this? Or we are searching any element in the binary search tree and we are asking the number of comparison, okay, required for the searching. So that type of questions, this is also very similar to the linked list type of concept, because if a tree will be given to you, so that tree will be created with the help of the linked list concept. Okay, left child, right child, like this. And this is, suppose this is a BST, binary search tree, and we are asking that find out the, like in this BST, find out the maximum element in log n time. Here also complexity may be checked. So how you will check? One thing is you can simply traverse the all the element with the help of inverser, in order and pre-order and post-order traversal, and you can figure out. Otherwise, binary search tree, to find out the maximum element, you can simply traverse on the right path. Okay, right child, right child, right child. Okay, and then you will reach at the maximum element in the binary search tree. So this is just like a log n step if tree is balanced. Okay, same things, minimum element will come on the this leftmost child. So that type of traversing you can do. So this is just like a recursive steps. So you can just check how you can solve perform this step. So some question I think is there in the mock, so you can solve that. And searching is also, so searching is similar to the binary search. Just check the root element and figure out that which side you should move, right side or left side, and then based on that move. But here this is just connected like a linked list. Okay, so you have to move like with the help of child information, child reference. So this is some type of like tree based question, not more than that. We generally not ask complex problem on that. Okay, so like complete tree creation or like this type of things, because you have time restriction of 2 hours. We also know that how much you can implement in the during the 2 hours. So some basic task is generally asked, which you can solve in the less time. So BST tree based question, and after that greedy also is the questions which are based on the like your week 7 content, not the main code I'm asking. Okay, simply like in that what was the problem actually, that scheduling problem. Okay, that interval scheduling problem, lateness problem, that is very simple actually. Just sort the element and simply just run just apply the iteration and check. So there's greedy algorithms based on some like interscheduling or maybe min max that you have seen in the assignment of week 7. So that is only required for greedy algorithms. And another is last DP, dynamic programming. Yeah, this is very wide actually topic. Here some practice is required, some like questions practice is required, but generally we ask easy question on this, not too much difficult. But DP, don't think about that. This will only be solved with the help of DP. Here also we are not checking the complexity. You can also use the recursive approach on that. So what approach you can apply, you can okay. So we are not checking any complexity. The questions may be solved with the help of DP, but that can also be solved with the help of different approach. So what approach you can figure out, you can apply. Okay. So maybe
Sir, total
some naive approach. Huh.
total how many questions are
Yeah,
there, sir?
total four only.
4 questions. Okay.
Huh. So one question on linked list and one question on graph. Another two question will be based on either binary search or tree or greedy or DP, like these four topics.
Okay, sir.
Okay, so DP problems, just practice on the questions which we are giving in the like week 9 we have given, and some mock we have given, and you can explore more. I think some TA have discussed from the lead code also, and you can explore some more questions, because here some definitely some your practice is required, but do not like strictly depends on the DP concept. Just apply the like recursive approach also for this. If you're not able to figure out the DP approach, just recursive approach means where we can explore all the possibility. So I hope we have seen this type of approach in the week 9 topic, if you can remember. Mm, week 9. So here is a Fibonacci series. You can see this is the recursive based approach. Okay, so here we are exploring solving each pattern. Okay, so we are solving each time. Another is like a second algorithm. This one. Okay, grid path problem. So grid path we are solving with the help of dynamic programming, but I have added the like recursive approach here also. Okay, you can see this. So recursive approach means from first location we are what is the possibility for the second location. So we will write all recursively. So we can either move to this side or we can either move to this side. Then this will be like grid. This will be explore each of the possibility. Like you can starting from this node. So either you can move to this side or you can move to this side. Okay, and from this position then what is the possibility. So this will explore all possible region actually. Okay, so this type of approach you can also apply. This is called as a recursive approach and naive approach. The complexity will be very high for this, that is 2 to the power n, but if that is solving your problem, so just you can write that also. So there is no restriction on this type problem. Okay, we are not checking any complexity for this, or you can figure out any simple logic that you can apply. So DP approach we cannot tell you any like important point, important like topic that has very large area. Yeah, Kiran.
So, sir, for finding the missing element using binary search, I just got a logic for that.
Uh-huh.
So, what I'm
Tell me.
doing is I'm getting mid element, and then I'm getting a difference between the first element and mid element, and the last element and the mid element, like, and then I'm
Okay,
comparing the
different.
length and the differences. So if they are not matching in that
Still
first,
you will not figure out that actually. Here
why
is
not?
also a one. Okay, I'm telling, giving
Like,
the example.
I'll mention the case for
No,
the
just don't think any particular case. Think about the all possible case. Okay, like I am missing
first I will
8,
check it across.
10, 11, 12, 13, 14. Okay, like this. Okay. So if you are looking, suppose your middle is coming at this point. Okay. Here you can see you are comparing the difference with this is one. Here you are comparing the difference. This is also one. Then how you will figure out that which side is small missing element?
No, I think you didn't know. This I will check. Okay, this is the first checking we'll
So
do.
Kiran,
After that,
when you are thinking the logic, no, just think about the all possibility, not just for any particular case. Do not create your logic for any fixed particular case.
Yeah, this is the basic checks we do for finding the missing number.
But
For
you
that,
cannot
we
figure
have
out,
to,
na? So by
yeah, we
this,
have to eliminate the remaining portion, right? So for that, we have to
so
I'm
after
trying to
getting
get
this situation, which side you will check? I'm asking this. Which side you will
yeah,
check?
that is what I'm saying. I'll try to get the difference between the middle element and the first element, and another difference for the middle element and the last element.
Okay,
And I'll check
you are saying
if
first
that difference,
element.
yeah, if that difference is not matching with the length of the left portion, like the length of the left
Yeah,
portion should be equal to the difference. If that is not, if the
that is
difference
looking
and
correct.
the
Yeah,
lengths
that
are
is
not
looking
matching,
correct.
then that portion should be the portion we have to check, and the remaining portion we have to, the other portion we have to
Yeah,
eliminate.
yeah, this is correct. Yeah, this is correct.
For length, we are
This,
just like getting constant time, no? So I think it's
yeah,
what.
this approach is fine, but this is not always the first position. Okay, so suppose if you are this is the first part, but suppose if you are reaching at this part, so you have to check with this part only. Okay, what is the last element, like this. So if you after middle element, not always the first, you have to check the first of this part or for last of this part. But okay, I think, yeah, first element. But some problem maybe you faced in this approach also.
Sir, any case,
Still,
this
you
is
are
a solved problem, sir, in one of the assignments, I think, or weekly live coding, I think. So we can refer
this
there.
problem you have solved.
This we have solved, sir.
Mhm. So Kiran,
Somebody,
just try. I think if this problem is available on the our problems, so just apply any type of logic with that problem, okay, and
Yeah,
test
sir.
your
I
logic.
think my
But
strategy is
this
to
looking
include
correct,
it.
but you have to apply some like validation also, because sometime suppose if you are getting this half part, okay, and your middle is coming where the left elements are total three and right part contains only two elements. So first, still you have to take the help of indexing. Otherwise, based on the difference, I think you cannot figure out, because you here this side difference will come like three. This side, if two elements are there, so you will get, suppose difference is two. Okay, so how you will figure out that that difference is always equal? Because middle may become like, suppose if you have four element, one, two, three, four. So here this middle element will either come on this part or maybe this part. So where the one part will contain only two element and another part will contain three element. So that difference may come.
Actually, I'm excluding the material thing.
So you can
That,
think this
I'm
logic
already
and write
checking.
your logic.
Yeah,
Write
since
your
I'm
logic and
already
take
checking
the
the middle element, before eliminating the other portions, I'm checking with the middle element only, like from
uh, no,
the
middle
either.
you have to identify it, na, how you will calculate the middle. So maybe if by the floor division operation. So that in that case, maybe you will get left half or right half with different size.
Yeah, I'm checking the
So
yes also. So is this available in the lead code? Right.
not lead code, but I'm not sure this is available in the B two assignments or live coding problems. So B two we have
sir,
not
it
live
is
coding.
either live coding or some graded. I think it is graded, sir. Uh, so I clearly
Uh,
remember this problem. So we can look there, sir. It's a simple problem.
so
Graded one.
live find peak, and I think second is find common elements. This is another.
We can use that Python tutor in the OPP, right?
I think yes, but don't like open too much. Okay, so that when you will use the Python tutor, so I think some new tab will be open, so your tab count will be increased. Okay, so do not open any another tab. That all things will be recorded. Actually, do not increase too much count. So that is for help. I'm not sure how much you can take the help of Python tutor. I think some another is also there, but
Sir,
use
but
limit.
this OPP is happening in portal thing, na sir? Portal's code
Portal
editing
only. Portal
facility,
only.
correct? So the switch
Uh,
will matter, sir. We can't switch to
uh,
other
No,
tab.
we will give some link Python tutor or something, but do not open too much. Like do not increase too much count of that. Otherwise, that will be actually checked manually if your count is high. Okay, so
Sir, our editor, will it provide some help about syntax, sir? Because it's not that we have coded too many programs, so we tend to forget the brackets,
no,
etc. sometimes.
so I'm not. So that you will get the error, na. So error is clearly indicate what type of syntax error is there. So error you will get when you will run the code. You will get the error.
Errors, okay. So, okay.
So that error you can figure out that what type of
Huh.
syntax error is there.
Okay, sir.
Okay, so
But
Kiran, just you can test this problem on locally also. Just take the input. Input is very clear. Okay, take any random input and test your logic. Okay, if that is working on the all type of possibility.
Yeah, sir, but maybe I'll post it on the Discord.
Okay. So DP problem, yeah, questions will not be very much difficult. Like we generally not ask two-dimensional DP problems. Okay, so two-dimensional means you do not require to maintain a 2D matrix for that. We will generally ask simple one-dimensional type of DP problem. Okay, so that will be easy. So just but practice on some similar type of problems, at least 10-15 problems you can solve. That is one-dimensional type of problem, and or also check how that problems can be solved recursively. Recursively means naive way, where you can explore all the possibility. So if you know the both type of approach, DP and naive approach, you can solve that problem also. Okay, so this is the DP approach. So DP approach is actually we cannot give any important topics. That is the common design strategy actually. But yes, solve all the assignments and live coding problems on the based on the DP. I think you can figure out based on that. So that is the important things for the OPP exam. So or partial marking will also be there. So for DP question, if you are not able to figure out at least some basic logic, then maybe some test case will pass. So that will also be help. Yeah,
Sir, other
this
problems also, let's say out of 4, 2 private cases are passed or some other
uh,
problems. So they will be given marks, na sir? Like,
yes, any partial private test case will get you will get the marks.
oh, okay,
Only private test case, okay, not public.
understood.
Huh. So that is the based on the test case. Um, okay, how many of you have solved all the mock questions?
No, yet to start, sir.
Okay, I
We
think
had project.
deadline is also there on the mock question. So solve before
23rd
that.
August.
Otherwise, deadline will over. Then you cannot. Oh, 24 August. Okay, that is for the last. Okay, that you have the time if your exam is on 17th. Okay, but solve all the questions before the Friday. This Friday, because Friday we will discuss all the solution of all 8 problems. This mock problems. So before that, you can also solve by your own. Okay, and you can also discuss your approach in the session, or maybe instructor will also explain the all solution. Okay, so any other thing? I think generally we are finding out that in the previous some terms students are doing much well in the OPP exam. Okay, and many students are getting full marks, like 10% students are getting full marks also approx. So that is
In OPP,
improved very well.
in OPP, sir.
OPP exam, I'm saying. Students are doing much very good actually in the OPP exam. Initial terms, we found that was very difficult. OPP exam students are not able to clear all 4 questions. But now previous 3-4 terms, the students are doing very well in the OPP exam also. Okay. So there is no passing criteria on this. So do not take any pressure. Just solve your question with the maximum effort. Okay. So there is no pass fail criteria on this. So
Sir,
without any pressure, just solve.
yes.
Hmm. Yes,
Sir,
Sandeep.
one request, sir.
Mhm.
Like I'm a working professional, and I know it is in our hands only. But I had taken three courses here. A judicious combination like system commands, PDSA, and one MAD1 project. So what happened is,
Hmm.
for both there is a OPP, and both the windows are 16th, 17th, and 23rd, 24th. And
Hmm.
unluckily, I mean, the MAD1 Vivas also, and there are two Vivas, which both of them have to be finished before 17th. So
Okay.
we were given very less flexibility, sir. So and
Yeah, so that actually we have also very restricted on the timeline. Actually, we cannot open this on the working days. So this
I know, sir, I know.
OPP exam.
But
So
what
because
could
of
have
that,
been done is, sir, like my Saturday evening 7 to 9, I have system commands OPP. Morning 9 to 11, I have PDSA. So
hmm,
uh, I was requesting ki, when, of course, the student portal will show that how many people are clubbed on this day. Somebody is like OPP alone, let's say not quiz 2 and all,
hmm,
are getting clubbed like
hmm.
this. 23, 24 slot is open, sir, actually. So I had
That
requested
is
to
open,
support.
but actually they have allocated all the things now till now. We cannot change, I think.
Any correct, sir.
And
What I'm saying is, if they could have looked at, if some people who have too much commitments on 16, 17, if some of them, not all, I'm sure they must have taken care. But if some students could have pushed to 23, 24, no, uh, it could have given
hmm,
some breathing time for
actually
practice.
this allotment problem is actually very big, difficult problems. Okay, so many
Yes, sir.
students, there are lots of combination of the course selection. Maybe some of
Interval
the students
scheduling.
not interval scheduling. This is a very difficult problem actually, because here too much variety students are coming. Some students may have the 4 course, and maybe 3 course have the OPP exam on the like in this duration. So they are first actually taking these type of students, how they can actually distribute the allotment. So they will get some time actually. They will get different slots also. So this operation team is actually works on that every student can give the exam. Otherwise, maybe some clashing will be there if they are not taking carefully. So, but you can send the request for them. I'm not sure. Maybe they will not change because there's
They
no
did not
change
change, sir. I
change
got the
facilities there.
reply.
Yeah.
Yes, sir.
Okay.
Okay.
I would
But
say focus on PDSA because SC has a re-OPP on 23rd.
SC have the another chance also. So what you can do, you can give the SC exam on the Saturday if you are not doing well. But that second opportunity is only for those who will fail in the first OPP.
yes,
So
sir.
you have to fail if you want to give the.
Yes, sir. So
So
you have to
that is
cook
the
up the
another.
failure in system commands. But
Uh, but they will not change, I think. So they
I
have
know, sir.
also
But
very
this point can be, at least when slots are available, no, and possibly. I mean, I know it's not
no,
possible always.
I don't think slots are available because there are
No, no,
too
I'm
many
not saying
students
not.
for the Python also.
Yes, sir. Not now. Always when a particular student has, let's say, 2 3 OPPs coming up for him, and those subjects have two occasions, let's say, like 16 17
Some of
was
the
one.
student actually gives the 3 OPP exam on one day actually.
Yeah, possible, sir.
That
Yeah.
is also a possibility.
But sir, they are doing full time studentship, so they can sit, practice
Not sure.
throughout.
That is depends. So generally,
Depends.
we at the time of registration, now we ask to the students do not take too much OPP exam in the same term to OPP course actually.
Yeah, yeah, we know,
So
sir.
if
But
they are working professional, do not take like 3 course which have the OPP exam or OPP exam. So generally, we actually suggest this at
yes,
the
sir.
time of registration.
Maybe two OPPs are manageable, sir. What happened is, project Viva's
This
dates were not fixed. That was the main this thing. Like, there was
so
last minute request.
you can request for the MAT team. Maybe they will change. Actually, I'm not sure.
No, no, sir. They told 18th is thing, so you have to finish. I have finished, sir. Madam, I have finished somehow. But
Okay, okay.
I was just bringing out the problem. I know there is no unique solution or this thing which will satisfy everybody. But
Hmm. Yeah, that is the
just
thing.
okay, sir.
Okay. Okay. Any other query? Anyone? Any specific query? Any doubt?
So do we get partial marks in OPP for
Yes,
every
yes, you
question?
can get.
Okay.
So suppose if out of five private test case you are getting two pass, so you will get like 20%, not 20%, 40% marks on that question. Okay, so five test case means each test case has 20% weightage. So if you're getting two test case pass, private only, okay, so then you will get 40 marks for that. Partial marking is there on the private test case. Okay,
Sir, can you explain the first question in mock? I can't understand.
first first question on the
Yeah.
mock question we will discuss on the Friday. Till then, you should try actually.
The question itself I don't understand.
Okay, question you are not able to understand. Let me clear this. One sec. Solution we don't want to provide actually because otherwise no one actually try it. So this question you can take the sample input or output to understand. So here this is saying you are given two list A and B of n positive integer elements. Okay, so means you have two lists with same size, okay, n elements. You can apply the following swap operation to them any number of times. So means how you have the list, suppose this first A list and B list I am writing here. So A list is there like 1 2 6 5 1 and 2, okay, and B list is there, so 3 4 3 2 2 5. So equal elements are there, six elements are there. Swap operation is performed only the same index. Okay, suppose if you are taking I index is 0 0 1 2 3 4 5. So you can only perform swap operation in these two lists on the same index. You can perform swapping on this 1 3 if required here, but you cannot swap any other, or you can also not change the position of the element, means you cannot sort the list or like this. Okay, so swapping you can perform like this, only the same index. After that, this is the possible operation you can apply on this list, and then you are calculating this operation. So max of the first list, max of the second list, and that you are getting this 18, and that should be the where what is the, yeah, which is the minimum possible value for max. So this value should be minimum actually in the all possible. Suppose in the given input, if we are selecting the max, so what is the max in the above? This is 6, and what is the max in the B list? That is 5. Okay, so here you are getting 30. But after applying this swap operation, how you can reduce this to the minimum? So here you can see some swapping is done. After that, we are getting 18. So how you can uh, perform this swapping to get the minimum, this multiplication, max of A multiply max of B. So this is the question, Kiran. So I hope this question is clear.
Yes, sir.
Okay, so think about that, how you can perform the swapping, and which list should contain which type of elements in the swapping. And that is very simple question. You can just easily figure out this, I hope. Okay. The simple idea for this, I am just telling you, just perform the swapping with each index and just take the max element among both element into the one particular list and minimum into the another list. Suppose if you are performing this swapping with zero index, so just keep the max element in B and small element in the A. Okay, so same apply for the second. Here also max, but here you can see 6 is max. So this 6 should be come here and 3 should be come here. Okay, so just apply this logic for the each index. Then you will get all the minimum elements in this and all the maximum element in the above. So you will get the minimum. So this is a simple logic for this. Okay. Any other query, Kiran or anyone else?
Sir, matrix multiplication, no? The code given in the class slides, I tried, sir, in Colab. It was not working.
Slides code you are, maybe that code I'm not sure that is complete, but you can take the solution on the our notes actually.
Okay, okay.
You have tried the notes.
Notes I have not tried, sir. I implemented as told in the slide. It's giving the answer,
So
but it's giving
dynamic
the.
programming you can.
Huh.
Okay, so here we have also explained the complete solution for that matrix multiplication. You can see this one.
Okay, sir.
Okay, so
Sir,
just use this formula, this code implementation.
yes, sir. Sir, and think,
And
I, yes, sir. Please tell.
uh so both implementation are given. I think this prof implementation is also given, which given in the slide. I think this one,
Huh.
and this is again another implementation. Two implementation are given. You can see which is related to you, which you want to check. Okay, both
Okay.
are working here.
Sir, day before yesterday, no, when our OPP revision was supposed to cover quick select and those algorithms, I had a system commands revision also, and that was only one revision, so I couldn't attend. But from last week, I had requested TA that the quick select slide needs some corrections, sir. The kth largest wala slide.
That I think we have discussed in the initial session today. So that is the mistake. Like professor assume that that is the they are solving. He's solving the kth largest, but actually he's solving the kth smallest.
हाँ
That
नहीं
is the
all
thing, na?
explanation is for kth largest, sir, but हाँ the algorithm
हाँ,
is for kth smallest.
that is something. I'll check with the operational team if they can modify the video content. I'm not sure, but other place like our notes and the slides on the portal, we have updated this. But in the lecture
No,
video, actually, that is not updated.
no problem, sir. Video can remain because we refer to the slides generally after watching the video only. But I have downloaded the slides. Slides still is the same as lectures.
But kth largest is given in the slide.
Yes, sir.
Okay, that I'll check that. Otherwise, in these notes which we are providing here, you can see the solutions are, I think, up to divide and conquer, kth,
So you have to check with the media team.
kth largest fast select.
DM, DM.
So this fast select, na, so this quick select, the fast select, and this problem. Kth smallest. You can see here we mentioned this kth smallest things. Um, we are solving this. Yeah, that is some like maybe typo or maybe some voice mistake. So I check that how we can correct that.
Okay, sir. Okay. But these are correct, no? The Git wala Git pages notes are correct implementation.
Notes all the implementation are correct. I
Correct,
think
right?
some place maybe in initial week also some prime that prime checking algorithm is also some issue is there. So that here just refer to these notes. Here all the
Okay.
corrected versions are there.
Okay, sir. Right. Sir.
Okay.
So, sir, what about for kth largest? So we had to change the sense, right?
So kth largest is also the same type of variant you can use. So means what is the meaning of that kth is smallest and kth largest?
Now
Suppose
for
you
the
have the
kth
list.
largest, we had to change the sense, right?
So just subtraction formula you have to use. So what is the size? Like you have the size. Suppose what is the length of this list? Okay, and like elements are given like 4, 3, 1, 2, 6, 5, 8, 9, like this. So largest means the what is the first largest is the this one. Okay, 9. Second largest is this one. But smallest means first smallest is this one. Second is this one. Like so we are looking this. Suppose question is I think kth smallest. Okay, so smallest k value suppose is 3. So what is the length of this list? So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so kth kth suppose largest we are asking, you can simply convert that to a smallest with the help of length. 1 2 3 4 5 6 7 8 elements are there. Okay, so suppose we are asking that kth third largest element, so that is simply a 8 minus 3 fifth smallest. So simply use the same algorithm for the same purpose, like, okay, just convert this. Third largest means fifth smallest in this list. You will get the same answer. Okay, so this is the only things you have to check. If you have the algorithm for kth smallest, you can also figure out the like another kth largest also. Just subtract the length minus that kth small, that value you will get. Okay, Kiran. Hello. Am I audible, Kiran? Your mic is off.
Am I audible?
You are audible. So this is clear. How we can convert the largest to smallest and simply apply the same algorithm.
I'll try it. Actually, I got lost in this part.
No, I am saying that suppose you have the algorithm with kth smallest, okay, and question is asking that fifth largest element, okay, largest. So how you can use the
So
same
then,
algorithm for this? Simply length.
so
What is the
then
length of that list? Length minus your this largest value. So you will get a small, that smallest number. Then apply the same algorithm. Your voice is breaking.
Acha, okay. So
Okay, so
we
this is the
want the
only.
fifth largest length minus the smallest, right? Smallest.
How so say you can convert the problem what largest to smallest or smallest to largest in simple this calculation. You're not audible properly. Okay. Okay. Any other query? Anyone?
There is
I think some network issues. Okay. Okay. Then if no query, then we can close the session. Just complete all these mock question before the Friday, and then we will discuss all these problems on the Friday. Okay. Thanks,
Okay.
everyone.
Yes, sir.
Bye.
Right.
Good
Thank
night.
you.
There is some technical. Okay. Yeah.